Alright, hello everyone. So in this video I'll be making a basic car controller script. So I'll just quickly play how it is supposed to be like. So it's going to be a very basic car control script with some basic physics concepts. So I'm just pressing W first here, and you can see the cars moving, and I'll just rotate it. So I haven't added any texture or anything as such to the game, but you can see it does behave somewhat like a car, but the physics is slightly slippery, right? So I'll quickly explain what's going on and how I'm doing everything, right? So I'll just rub the script off, and first I'll just declare the script itself by calling the mono behavior object, right? So we have the basic script ready. So when you are making a car controller, so there are three things which comes to my mind. No, so not paint. All right. So when you are making a car, just quickly draw things so that you can understand what's going on. Assume this is your car, right? So the first thing is that the car is moving forward, but there are multiple things that comes in mind when a car is moving forward. So the first thing which comes in mind is the drag concept. So you can consider drag is a term like, suppose the air is moving like really fast, and when the wind is moving very fast, it causes to have an impact. It causes to affect all the objects which are in surface, right? So the main purpose is to basically slow down an object's movement, or the object's linear movement while it's moving. So it basically causes change over the friction. And the second thing which comes to the concept is angular drag, right? All right. So if you suppose this car is trying to rotate, so if you have seen in F1, like normally what happens is like the slides, the roads are like curved, and also you'll be probably curving here and there. Sorry for my bad drawing, but yeah. So you can see the car body which you are seeing here, so it rotates here and there, but there is this concept which comes to play, which is your angular drag. So let me explain what it basically means. So angular drag is basically the friction that happens in the surface when you're basically rotating. So if there is no angular drag, you can expect that the object will be like rotating fully. It will be just be like rotating, and it will be like as if you're moving in ice. So like there is hardly any friction in ice, you just keep going. So that's the thing. The third concept which comes here is basically time, not time basically, but magnitude. So, sorry, quaternions, right? Quaternion. So, this is a different thing itself. So, this is basically how you represent rotation in Unity. So, basically, it comprises of four values: x, y, z, and w, right? But we'll be representing this using Euler angles, which allow us to represent using x, y, and z itself. I'll just quickly show how this thing is supposed to work. So here's a player script. I'll just show how rotation is supposed to work here. So if I hold this thing, so you can see there here we have like four things here. So this is the x, y, z, and w, right? So if you use x, so it will be just going like this, the red line you can say. If we do y, the y, if we rotate using the y axis, it will be like going here left and right using this green circle. If we press z, so what z is going to do is basically it will be can just basically rotate it, sorry. And w is basically a combination of all these things basically. So I think w comes, I believe, as, just a moment. You can see I am holding this yellowish line, and if you can see over here in the rotation string here, so just quickly observe what I'm doing. So I'm just moving this, and you can see all the three values are being moved. So W is basically a combination of all three values X, Y, and Z. So these are the three core concepts which come when you are making a car controller. so that you can make a car controller which is slightly realistic and you're not making cars just slipping over ice. So alright, so now it's time to declare a variable. So this will be a physics based car controller. So you have this the whole thing, like most of the calculations are being here done by Unity, but still I believe some of knowing the concepts might be of huge help. So I'll just firstly do uh alright, no, sorry, require component type of rigid body, because cars cannot work without having a rigid body. So I'll just quickly define the rigid body difference, and I'll call the start function, and I'll do the infamous, not so infamous method, rigid body get component rigid body. So what this basically does is, so if you have seen here, I have defined the rigid body as private, so I cannot access it from the inspector. So oh, I forgot to save this. Oh, so if you see right now, save this, so you see I cannot access the rigid body component from the inspector, but I have declared it here. But what I'm doing is, when I'm playing when I'm starting the game, so what is happening is that I am directly setting the rigid body, so I'm getting access to this component and I can do whatever I can once the script is played and the start function has been executed. So this is our first start function. The second function is basically we need to define the values for which we are needed for controlling the car. So in this car, we will be doing three things. That is, we will be moving forward, we will be rotating, and also what we want to do is that we want to limit our speed, just so that we don't like get out of friction control. Because if you see, we have to calculate things here. Unity doesn't have its, this is a game engine, so this is not like some real life simulator where we can, the things already predefined. Sure, you could do those things, like, but that's somewhat, that will be taking a lot of time, so that's why we are doing these calculations before in hand. So let's begin. First I'll do is basically physics based values. The first variable which I'll be calling is acceleration. And I'll be calling this, I think right now I'll just keep it null. I'll just keep it 0, because and there's a reason why. If I want, I could just keep it 20 here, which means I'll be moving 20 values, 20 blocks per second, but that's not something I want. So I just want to calculate that already. So the second thing which I'll be doing is I'll be calculating the steering. Alright. So these are the main two variables which you need, but then there is one more thing you might need is basically input handling movement. So what input handling movement is, like you will be pressing W or S to move forward and move back, or an A and D to rotate there and forth. So you need to ensure that, sure, what you could do is basically you could just go to update and you could write input dot get key down, but then there'll be like way too many check marks, because trying to calculate for like where to go from W, S, what to do for A and D. We have to have four different checks, and that's not convenient, right? So we won't be doing that. Alright. So for that, I'll be giving two private float variables, which is input forward and input steering. I think the variables pretty well define themselves. So this is basically vertical based movement, and this is horizontal based. So pardon me for the error, right? So now, okay, I forgot to mention two other variables, which is the drag and angular drag, angular drag. So let's just complete with what we will be doing with drag and angular drag. I think that's going to be pretty easy. So first we'll be just basically defining the drag variable from here itself, and angular drag also from here itself in the start component itself. So we are basically predefining it, because we can edit it as how we want it to be later on in the inspector, so that when we are editing with physics, right? The third thing which I want to add here is basically I want to add a center of mass, so that I can basically have a better control over the object's rotation. So I'll keep it, I'll make it a vector tree, and I'll define the y position at minus 0.5. There's a reason why. Just a moment, I'll explain this to you very well. So I don't know why I kept it. So what basically this is doing is, so right now our center of mass, suppose let's say it's 0 right now, which means I'm controlling it from the middle position here. So you can see this is the center of mass, this middle part. So what I'm doing is basically, I'm instead of keeping it in the middle, I'm keeping it over here, like the ending in the, how do I even describe this, in the upper center, sorry, lower center. So I'm keeping this point in the middle to lower center so that I can have a better control when the object is rotating. So it will just help in, just help, although it's very optional if you want to keep it or not, but I'm just keeping it so that I can have a better control over my object, right? Now now we have defined the main variables. Now it's time for doing the main coding, which is handling the acceleration and handling the steering. Just a moment. All right, so I'll define a fixed update for this. There is a reason why. Because we'll be doing all the calculations in fixed update itself. There's a reason, because if I keep update, which means let's assume if my game is having around 60 FPS, which means it will be running 60 frames each per second. So if I even keep the speed, suppose I say 20, and if the FPS of someone is 60 or 90 FPS, so it becomes quite unfair, because then we are just breaking the game speed component. So someone can get like 120 FPS, 60 FPS, although if I want, I can play with optimization, but that's a horrible and horrendous idea. You shouldn't think of doing that way. So this is why I'm using fixed update, because basically fixed update is that each frame is being called per 0.02 seconds. I'll just keep it right here, 0.02. Alright, and now let's do the main thing. The first method which I'll be defining is input handling. Then I'll just define it inside the fixed update, and I create a method for same input handling. So the first method, what we are basically going to do here is basically we will extract the input base position for the two float variables, input forward and input steering. So I'll quickly explain this to you what we are talking. Get axis vertical and input steering input get axis horizontal. Now you might be wondering like what is this basically going on, so I'll just quickly explain this. I'm sure some of you all understand this very well, but I'll just quickly explain to this. So what I'm here doing is I'll just quickly create a small graph. So wait. So this is our graph. Assume this is our car's graph. So I'll just add a rectangle over here. Assume this rectangle is our car. So you can very well understand this point, this arrow, we are and this arrow, the this one arrow which I'm talking about, the straight line arrow, which is the vertical arrow. So this is pointing towards we are going forward, and this part is pointing that you're going backward. Here you are pointing that is going towards the leftwards, and this towards the right side, right? So we are basically here calculating that input forward, the float variable will be calculating the vertical position, and it will be returning only two values, either it's 1 or -1 or 0. So I'll just quickly explain what basically I'm trying to say here. So 1 basically means that we are going forward. So we are going +1 in the world space of unity. And if we are pressing backwards, so S button, so we are going -1. So we are going -1 backwards towards the world space of unity. And 0 basically means that this value is untouched at all. And the same applies for the horizontal part. So if we are basically pressing, let's say we are pressing D. So assuming you are in this moment. So sorry, we are pressing A, because this is supposed to be +1, this is supposed to be -1. WASD. So if you're pressing +1, you're going forward, you're going +1 in the X direction, world space unity, and if you're pressing -1, so this you're going in the -1 direction, X unity. Now since we are working this game in a 3D, this is a 3D game, so we cannot consider this as a 2D vector. So this is a full 3D vector. We'll be assuming this as a Z space, and this will be our X space. All right. So now let's go back. I hope you have understood what basically this I'm trying to say. So now what we'll be doing is we'll be basically handling the forward movement of our car. Move forward. Basically, now when we are moving forward, so there's a quick core concept which I've previously already explained here, which is basically force, acceleration. So what we are basically doing here is we have two ways we can basically do our movement using car in unity. So first thing, obviously we'll be following the first step, which is basically we'll be applying the force to the car every 0.02 seconds, because cars normally work by force. So when you're hitting the accelerator, so we are forcing and it's getting ahead. So that's what we are doing. What we could do is we could basically do rb dot velocity new vector 3, and we can do that, but then there will be no force or nothing as such. So we'll be basically applying the force to car every second. First we'll just get vector 3 forward. So what this vector 3 does is basically we are basically calculating every frame how forward we are supposed to, how much forward we are supposed to go. So how we are calculating this, basically we are taking input forward and we are multiplying it by acceleration, and we'll be multiplying this with also transform dot forward. So this is a vector 3, just to let you know. So this will be represented as x y z, right? So what we are doing is input forward is your this vertical position. So if you are pressing it, so this will be +1. And acceleration, let's assume we give it some value like 20. So 1 into 20 becomes 20. And transform dot forward is basically a vector 3, which is represented as 0, 0, comma 0, comma 1. So basically you are just basically multiplying it with 20. So it Unity will very well know, like we are basically trying to go forward, so it will just add to the z position. So, and now what we'll be doing is basically we'll be adding force to this. So we'll be adding force to this, but there's a problem. So we are at every time adding force to this, but then what happens, then we want to take one thing in mind. In what type of force are we trying to add? So do we want to consider the mass of the object, or do we want to just like move it directly without considering the mass of the object and it moves smoothly? So what I would like here is that, since because this is a car, so if you want to make a realistic car which can move easily, and taking in mind the physics of the car, the weight of the car, so you can write force mode dot force. But since I like to prefer for force mode or acceleration, just so that you can get more speed and play with values much easier, so that's quite fun for me. So however, just for the sake of this tutorial, just give it force mode dot force. All right, now this is the first thing in this is the move forward function. Now we'll be doing steering, move steering. Now what here we want to do is basically we want to imagine a scenario where the car is basically trying to rotate. This is the road, and we are this car, and we have rotated, and we are here now. Alright, so we can only represent rotation in Unity using quaternions. I've explained the concept of quaternion very well, so I hope. So we'll define a quaternion, Euler dot Euler. So this is expecting a vector 3. Alright, so vector 3 rot is equal to, I'll just write steering, input steering into acceleration. Sorry. Input steering into steering, and I'm sure expecting vector 3, so we cannot convert it like that. Just a moment. Just a moment. So vector 3 input steering into steering. So what here we can see that. Um, Wait, I'm actually thinking here. So what we can do? So think this is probably what we are supposed to do. Although I'll just quickly check for why. Basically, what I'm doing is basically transform that, right? Basically means we are pressing A or D. So this can be either +1 or -1. And input steering. So your input steering is basically this horizontal base movement. So this can be also +1, -1. So this is basically we are defining the vector itself. So yeah, that's the thing. And the last thing we want to do is that we want to basically limit the movement of this car. So limit based movement, right? So oh, no. So one thing is basically now you want to ensure that your car is always moving under the surface. Am I right? So this thing might be pretty tricky to get because your car is moving under the surface, but you don't know if it's in the surface or not. So you need to always keep a check if the car is continuously in the surface, like in a ground on not in the air. So what we'll be doing is basically here is we'll be casting a ray cast from the car spare's body. We'll be casting a ray cast and we'll be casting a small thin line, and we'll just it will be straight line, and we'll be checking if this line is touching something. So this line is touching, which means we are recasting with some surface. So that's how we will be doing it. So for this recast, transform the position vector 3 dot down. We'll take a recast it variable and layer mask. Just a moment. So we want a layer mask also. So in we'll basically add a layer for each foreground object so that we can perfectly distinguish between each of them. So layer mask, layer mask, get mask, ground layer. So this will be probably the name of my ground. So 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 what we are basically here trying to do is that when we are ensuring that that this always remains in ground. So we are casting a recast from our transform position and we are casting it a bit downwards, and this hit is basically object if we hit from the line, and we want to ensure that we are hitting an object which has this layer mask. Now what we want to here do is basically we are just defining how long this line should be. So the length of this line, right? So the length of line should be 1f, but I'm basically that I'll just define a constant for this. So layer line length 1f. Oh, very sorry. This is what happens when you are like continuously using Unity and you are defining everything using F, because most of the time you are defining values with float variables since you are calculating minor stuff here. Also, that's sorry. Pardon me for that mistake. Alright. So what I'm basically doing here is that basically if we are raycasting, if we I'm successfully hitting on something, so we'll be allowing the script to okay, you can like move forward also and you can move your steering also at the same time. All right, and I'll just quickly explain what this method is does. Move rotation. So move rotation basically means that we are making our rotation move at upon something. So this is our rotation. So it will be moving like this. We are playing with the y value. So oh, wait, I think I got it. Why I'm actually did a mistake here. So oh, okay. All right, guys. Okay. Now wait. Let's explain what is basically got wrong here. So just a moment, just a moment, just a moment. This was a heavy mistake from my side. So what was going on is basically, actually, I took this float rotation value, which is basically multiplying the input steering with the steering value. So what steering value is basically, we have defined predefined steering value. Let's say two blocks. So let's say two. So it will be rotating two blocks per second. So we are multiplying variable rotation with input steering and rotation. So if we are rotating, so let's say we are rotating towards the A side, so it will be plus 1. So plus 1 into 2, so the 2, so the value will be 2. So then we are defining a quaternion, and we are defining it using the quaternion Euler angles, just so that we can define it in unity itself. This is nothing else. This is basically, we are defining the rotation values in the unity space using Euler angles, and not using x, y, z, and w, because the original values of quaternion are x, y, z, and w, and not x, y, z. That's why. So here we are defining a Euler angle, which is, we are basically do nothing in zero, but we are defining the rotation, this floating value in the y-axis, and we are keeping the z-axis unchanged as usual. And now what here we are doing is the main thing, which are basically, we are allowing our object to move as across where this rotation is supposed to go. So let's say, I'll just quickly give you a code example, because it's very hard to understand this in theory. So suppose I say the your rotation, your rot 2, and you have this quaternion of yours, so we are xyz. So rot is equal to 0 to 0. Now what here we are doing is basically, we are rotating towards plus 2 every single time. Once if we are pressed that the horizontal keys, and then we are allowing our rigid body object to move as per how the rotation is going. So this is how it's supposed to be. So 2, so you're like minus 2, I'll do this, so it will go there, minus 4, 6, 8, 10, 12, 14. But you know that unity is pretty fast, so we are doing calculating here for per frame instead. That's why. Um, right. So yeah, that's the thing. Now, one last thing which I want to do is basically, I want to allow my inputs move speed to move forward, because what happens is, suppose when you're in a car and you're hitting the accelerator, so the car speed keeps increasing over a period of time, and you can limit that speed itself. So this is one feature which I wanted to add, and let's do that by first creating a method called void limit speed. So at the start, I'll just ensure my acceleration is 0, and now what I'll be doing here is basically acceleration. Now that my acceleration is 0, so um basically what we are doing is acceleration dot plus time dot delta time multiplied by 10. So what here, because I'm pretty sure you're confused, like why are we like multiplying it by 10. So if you, the default value of time dot delta time, so if you're in, suppose, let's say 60 fps, so it is the default value. I think it is going to be 0.016, or if you're in 30 fps, it will be 0.033. So we are just basically multiplying it by 10, so that we can quickly rotate, because that's one thing which you need with cars. That's why. So if now one, I'll just quickly add one small constant here, which is private constant max speed, and I'll keep this 25. So if your acceleration is more than your max speed, okay, wait. For this, what there's one more thing which I need to do. Um, so if your acceleration is more than your max speed, then what you want to do is basically, you want to ensure that it does not go overboard and it remains as max speed itself. But just a moment, there's a small problem with this, which is like, you're continuously adding it over a period of time. So even if it's not moving or not rotating, so that can be a problem. So I'll just, no mind, we have already done the predefined calculations here, so I don't think there can be any problem, anything else. So last thing which I probably want to do is I want to add one more way of limiting the speed also. So this is actually one of the ways. Another way we can actually limit our speed is basically we'll calculate vector 3. So vector 3 clear pause new vector 3. We are basically I don't think as of now we have any slope, so I'll just keep it zero, the y-axis itself. So first we have defined a vector 3, which is the player position, and here we have defined, and the three values which we are taking here is basically the x position of our player and the z position of our player. So here what we want to do is basically this is another way how we can do this. Now let me quickly explain what is basically going on. So this is one of the ways what we are actually. So I'll quickly explain this to you what is going on. All right, just a moment, just give me a moment. So if you look at acceleration, so we are adding it with time dot delta time, so let's assume it's 0.16 into 10, so it becomes 0.16 per second, right? So what here we are basically done doing is basically calculating the magnitude every single time. So let's assume our x position right now is, let's say, 0 4 3. All right, y as usual 0. So and z is, let's say, 4. So our z is 4 and y is 3. You can imagine it something somewhere would like something like here, if this is the road. So if never mind, bad illustration. So what here now we are doing is basically we are calculating the magnitude every single time. So how we are calculating the magnitude is basically we are basically doing the square root for each. So basically 9. This is basic, very basic maths. So this is the this will be our magnitude right time, which will be the length of our vector. So if this 5 is greater than 25, obviously it's not, so we can continue going with that speed itself. So this is another one other way we can do our limiting of speed. And I think this is we are done with calculating our we are done. We have finished our basic car controller. Let's just have a quick test over it. So I'll define acceleration. So you probably very well know that we don't need to define acceleration, but yes, we need to define something. So the drag I'll basically define everything as 0.8 and angular drag as 0.2. Now let's have a quick test. Just a moment. You can see our car is actually moving pretty slowly, so that's but it's indeed moving. That's one thing, can see that. Uh, One thing I'll do is, since it is because we have predefined this as the NF itself, so I'll just add a public float, add force. And you know what? Instead of adding it with this, I'll basically do. Now I think everything seems to be cool. So add force 2.5. Now this will be actually very fast. So and drag 0.8 is slightly above normal. So I've just pressed W, so if you see it will quickly pick up, and that's how actually cars are like somewhat supposed to work. So if you see, we have actually kept the rotation as 0.2. That's why it's actually like freezing somewhat. So I think I need to probably reduce this angular drag. Uh, yeah, and I have to also reduce the drag itself. Now you will see it will. I'll just keep it extremely low, so you'll feel like you're like slipping in ice or something. it's picking up the speed again. So, oh, 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 it actually does feel like we are slipping in nice. Ah, and I got out of the game world itself. So I just for the sake of it, I'll just increase the speed because, and I'll keep this point 0.5 and I'll keep this as point 0.1. I think these are some of the perfect values. Yeah. So that's it. I think that's the video itself. So this is the script. You can copy paste it from GitHub or you can try making it yourself. So yeah, that's the video, guys. I hope you liked it, and yeah, bye.